The eagle has landed. Welcome to Maths. This is Mangeya, the Maths Eagle. Right. This video is on circle geometry, how to solve angles in a circle. Then after watching this video, please like, share and subscribe to this nice, powerful item. Right. Then in this video, you learn about the theories associated with circle geometry. They have been explained, then followed by the questions, past exam questions. They've also been worked out in this same video. Right. So you have to understand, number one, the theories in circle geometry. Then the other thing that you have to understand also are angles and parallel lines. That is the Z angles, the alternate angles, corresponding angles, opposite angles on straight lines, the adjacent angles. All those ones, you have to understand them so that you can be able to tackle problems involving circle geometry. Then the other things also are angles in a triangle that they add up to 180 degrees. That one is key because most of the times you can be working with angles in a triangle. Then the parallelograms, also have to know the general properties of parallelograms because you can also find them inside a circle. You have to know them, right? Then theory number one on circle geometry. Theory number one, it says angle at the center is twice angle at the circumference of a circle. That is, angle subtended or formed at the center of a circle is twice angle at the circumference. Circumference is more like this. Angle, let me write it down. Angle at the center is twice, which means it's 2 times. Is twice angle at the circumference. Right. How can you see this angle at the center and angle at the circumference? It will be like this. This one is the angle at the center. Then at the circumference, they are supposed to be coming from the same points. Like I can say A and B in this case. Right. Angle at the center, which is this one, then angle at the circumference is this. If my angle at the circumference is x, then angle at the center is 2x. That is twice the angle at the circumference. Which means if this angle is actually 40 degrees, then this angle is supposed to be 40 times 2 is 80 degrees. Just like that. So that's the first part. Then this same concept or theorem can be presented in another form. It can be like this. Then angle at the center, then this one can be somewhere here, is still at the circumference. In this angle, if this angle is x, then this one will be 2x. That is twice x. Then it can also be presented in this form. It's a quadrilateral, actually. Then angle at the circumference is this one. That will be x. At the center is this one. It will be 2x. That is twice the angle at the circumference. So these are the different dimensions that you can be able to see based on the on theory number one. Angle at the center is twice angle at the circumference. Then theory number two. Number two, it says angle subtended or formed by the same arc are equal. Angle subtended or formed, subtended by the same arc they're actually the same. Same arc. If I can mark this arc, I can say A and B. This is my arc AB. I can consider this side. Then the angles must be starting off from these points A and B. Like this. I have this angle whose lines are coming from the points A and B. I can call this one X. Then I can have another angle also. They must all be touching this arc. Then this angle will be X. Right? Take note of that. So these angles, they must be coming from the same points A and B. Therefore, they are said to be the same. Even if there are many or lots of them, it's still the same concept. This one is A and B. This angle, I can call it X. Then I can have this angle. I can call it X. Then this angle. It doesn't matter how many angles are there. But all these angles, as long as they are coming from the same points A and B, these angles, they are said to be the same. Right, then theory number 3. It's more like the number 2. But this one, we have now a chord. A chord is a line that joins from one point to another point of the circle. Like this one is called a chord. Then a diameter is also a chord, but it's a special type of a chord that divides the circle into 2 equal parts. That's a diameter, it's a chord, right? So this one is called a chord of a circle. Right now, if I can have a chord, let me draw my chord here. This is the chord. Then angle formed by the or coming from the same chord, I can also call this chord AB. Then I can develop my angle from these same points A and B. This one is my angle. I can call it X. Then from the same, I can develop another angle to the circumference. Then this angle will also be XY because they are coming from the same chord. This one is AB. They are therefore taken to be the same or equal. Right, I can have so many chords. Like if I can draw like this, then I can have this one. I can have, then I can have another chord here. Right, this one is the chord on the circumference. This chord, let me call it AB, then C, then D. So if we can be at chord AB, we can say this angle and this angle, they're the same. It's X and X. Then go to chord BC. If you can go to chord BC, then chord BC. Right, for chord BC, it means this one. It means the angles which are the same, which are coming from C and B. We can have this angle here. I can call it Y, and this angle is also Y. Right, so allowed even to turn your paper so that you can be able to see clearly. Please take note of that part. Then let's go to this chord. Then that is AC. Right, this one AC. So if you are now at AC, then you can see what? We have 2 angles that are the same. We have this angle at AC, this angle here. If I can call it T, then this angle is also T. Then last one, we have the chord that is AD. Chord AD, right? This chord AD is this one. So you can see this angle, which I can call Z. The same as this angle, I can call Z. So that's how we can be able to illustrate based on this theory number 3, angles subtended by the same chord, they are equal. Right, then theory number 4, angles formed by the diameter is a right angle. Angle subtended by the diameter or formed by the diameter, subtended by the diameter. By the diameter is a right angle or is 90 degrees. Is a right angle or is 90 degrees. Right, diameter is a line that divides the circle into 2 equal parts. If this one is my diameter, we send a O. Then if I can join the angle from one point of the diameter, point A, to point B of the diameter, then this angle up here must be exactly 90 degrees. It's a right angle, right? If I can even present the same item in this form, let's say I can present it even down here, it's still the same thing. If the angle is here, it's still 90 degrees. Even if the angle can be somewhere, even if it can be somewhere here, it's still 90 degrees, as long as the lines which makes up the angle are coming from the points of the diameter, that is A and B. So that's theory number 4. Then theory number 5. Theory number 5, it says this one, if I can draw my radius and I draw another radius here on a circle, then this radius and this radius, they are actually the same, right? So if they are equal, if I can now join these 2 radii, then they form what is known as an isosceles triangle. Isosceles triangle. So if to take note of the angles in an isosceles triangle, this angle and this angle, they are the same. If this angle is x, then this angle is x, which means base angles of an isosceles triangle, they are actually the same. They are equal. So this one is another theory. Then the next theory, number 6. This one is the exterior angle of a triangle is equal to the opposite interior angle. The exterior, that's the outside angle. The exterior angle of a triangle is equal to the opposite interior angle. It applies on circle geometry to the opposite interior angle, that's the inside angle. That is opposite the exterior. Like in this case, if I can draw my triangle like this, and there is usually a tangent. Let me draw my tangent. Right, let me draw it this side. This is my tangent. My tangent. A tangent is a line that meets the circle at only one point. That's called a tangent. So this angle is the exterior angle. I can call it x. Then the opposite interior angle is this one. This is the angle that is opposite this one. So if this angle is x, then this angle is supposed to be x degrees, right? So that's the opposite interior angle. That one is actually key, right? Then the other theory is based on a chord, on a tangent. If I can draw my tangent here, the tangent meets the circle at only one point. So this one is based on tangents, right? If I can draw a line from the center meeting the tangent, it meets the tangent at 90 degrees. So it means the angle formed where the line from the center meets the tangent to the circle is actually 90 degrees. It's a right angle. If I have my center O in this case, right? Then next, if I can have the other one based on these tangents, right? So if I can have two tangents, right, joined together. Two tangents joined together, it means from this point, I can say A, then C, then this point is B. AC is actually the same as BC. They're actually equal, which means AC, this side and this side, they will be exactly the same. Now, if I can extend my shape, let's say I can put my center here, then I draw a line from the center, meeting the tangent at A. Then the angle is 90 degrees. Then meeting the tangent from the center at B. Then the angle is also 90 degrees. It's a right angle. Then this shape you can check. It's a kite. Because this side AO. AO is the same as OB. Why? Because these are two radii of this circle. So they are the same. So this one will form a kite. A kite is made up of two isosceles triangles. If I can have this triangle, this side is called this side. This one is an isosceles triangle. Then I can have another isosceles triangle where this side is the same as this side. Then this shape that will be formed is actually called a kite. Kite. So for a kite, if I can divide the diagonals, they meet at 90 degrees. A diagonal is a line from one corner, like from A to B. That's called a diagonal. And the other one from C to D is also another diagonal. So in this case, there are two diagonals of a kite. Diagonals AB and diagonal CD. They meet at 90 degrees at right angles. Then the other thing or property of a kite, if I can, then diagonal CD, take note, diagonal CD, it bisects angle at C into two equal parts. If this angle is X, then the angle down will be X. If this angle also at D, it will be bisected. To bisect is to divide into two equal parts. So angle at D will be divided into, if this one is Y, this angle down will also be Y. So that's the same. If I can join here my line from O to C, then this angle at the center will be bisected or divided into two equal parts. If this angle is X, then the angle down is X. If this angle is Y, this angle down will be Y. So you can see that this kite is made up of two right angle triangles. You have this right angle triangle, this one, shaded black, and the unshaded one. They're actually two right angle triangles. Such that if you can be asked maybe to find the distance or the length of the line, you can be able to apply the concept of Pythagoras theorem. You can apply SOHCAHTOA. That's the method used to solve right angle triangles, sine, cos, and tan, using the tricks. Right, then the other thing is now based on cyclic quadrilateral. Cyclic cyclic quadrilaterals. Cyclic quadrilateral. A cyclic quadrilateral is a four-sided shape that is inside a circle, all of whose sides touches the circumference of a circle. That's what is known as a cyclic quadrilateral, right? So if I can draw a cyclic quadrilateral here, it will be like this. This one is my circle. Let me put a proper one. Then I can put another one. Right, so a cyclic quadrilateral, if I can right, so if I can have this circle, let me put this one down a bit. If I can have this circle, then my cyclic quadrilateral is like this. Let me change ink. So this one is my four-sided shape. Actually, it's inside a circle, all of whose sides must be touching the circumference of a circle. If it's like this, you can see that this point, this side at all is not touching the circumference. So this one is not a cyclic quadrilateral, right? This one is not a cyclic quadrilateral. However, you have to apply concept or law number one, that is x and 2x. So this side must be touching. So it will be, if I can develop it like this, then if I can say A, B, C, D, this will now be a cyclic quadrilateral A, B, C, D. Right, then there are two theories that are associated with angles in a cyclic quadrilateral, right? Then theory number one, if you can have this angle and this angle x and this angle y, we can say x plus y is equals to 180 degrees. Basing on what? We say opposite angles of a cyclic quad are supplementary. Opposite angles of a cyclic quadrilateral are supplementary. Supplementary means add up to 180. Add up to 180 degrees. Like this. So the opposite angles, we can have x and y. If we can also have this one, t and p. T plus p is also 180 degrees. T plus p is equals to 180 degrees. Why? The same rule applies. Opposite angles of a cyclic quad, they are supplementary, which means they add up to 180 degrees. Right. Then the theory number two, this one is theory number one. Then theory number two of a cyclic quad is the exterior angle of a cyclic quad. If I can draw it like this, the exterior angle of a cyclic quad is equal to the opposite interior angle. This angle is exterior if it's x. Then this angle inside is also x. So theory number two says the exterior angle, that is the outside angle of a cyclic quad, the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. To the opposite interior angle. So that's this law, right? You can also develop this side. If you can develop this side, let me use different ink. If we can develop this side, let's say this side will be developed, then this one will be the exterior angle, it's y. The angle opposite this one is this one. It will also be y. Take note of that part. So if I can draw another one, then I can develop this side here. Then this angle x then the opposite is this one. That's x. That's the opposite interior angle. Right, so these are the theories based on cyclic quadrilaterals. Right. Right, theories in circle geometry. I'm sure you've seen them, you've understood them. Then going or moving on to the questions. To the questions proper. Right, this one is question number 1. It's in the past exam paper. This one is for Cambridge. Right. It says the points P, Q, R, and S lie on a circle with diameter PR. So this diameter PR is the diameter, which means we have our center. Our center, maybe we can put it somewhere. Here. That's my center, eh? Then they said, work out the size of angle PSQ. PSQ is this one. That's the angle that you have to find, giving a geometrical reason for each step of your working. These are 3 marks. Right. Diameter, we apply theory number what? Theory number 3. Let me go to the theories. This one. Theory number for the diameter. So you just have to apply the theories. Is this one. Angle subtended by the diameter is 90 degrees. It's a right angle, right? So that's the one that you have to apply. Why? Because there is a diameter. So whenever you can see a diameter, that's the one that you have to take note of. Which means angle PQR is equals 90 degrees. Reason, you write angle subtended by the diameter or formed by the diameter. Subtended by the diameter. That's the first stage. Then you can put your 90 degrees there. Then you have to find, you can see angle P. Alright, check code PQ. This code PQ. It's a code, this one. It's still number what? Number 2. Angle formed by the same code or subtended by the same code, they're actually the same. Which means the required angle at S is the same as the angle at R. Like this. You can see why? Because they're coming from the same code PQ. You can also say angle from subtended by the same arc. They are equal. This one is the arc. Still the same concept. You still get the same answer. Right? But let's use the code. So you can say angle, then PSQ. That's the one that you are looking for. Is equals to angle, then PRQ. Why? You can put this sign for angle. Then you can say angle subtended or formed by the same chord. Even if you can say arc, it's still the same. Angle subtended by the same chord are equal. Then if you can find PRQ using triangle PRQ, triangle PRQ. So you can use angles in a triangle, right? So you can say 29. Actually, let me say P. Therefore, PSQ with the same as PRQ is equals to 180 minus 90 minus 29. Using triangle PRQ, then this one you can say angles in a triangle. Angles in a triangle, they actually add up to 180 degrees. So triangle PQR or PRQ, then you can punch in your calculator 180 minus 90, it will be 90. 90 minus 29, then you get 61. So this angle is actually 61 degrees. Then done. Next question number B. They said, right, this one is our circle. The points A, B, and T lie on a circle, and CTS is a tangent to a circle at T. So it's a tangent. So whenever you can see a tangent, you have to check. Is the line from the center meeting the tangent? In this case, no. Then it means the angle can be 90 degrees. But because you know that where a line from the center meets a tangent to a circle, the angle formed is exactly 90 degrees. Right? Then ABC is a straight line, and AB is called BT marked. AB and BT marked. Then angle ATS is 98 degrees given. Work out the size of angle ACT. ACT. So I want to find this angle. This is the angle that you have to find. So if this angle is marked, these lines AB and BT, they are the same, they are marked. Right? In this case, you have to apply this theory. Theory based on the exterior angle of a triangle is equal to the opposite interior angle. Where are you? This one. So this theory number 6, that's the one that you have to apply in this case, right? The exterior angle is equal to the opposite interior angle. So you can say 98, the opposite is this one. That's the opposite to 98. So this angle is exactly 98 degrees, right? Then since this angle is the same as 98, we can find this angle here and this angle, they are the same, right? Then after finding these angles, then you can find these angles. Let me mark them in blue. This marked in blue, this and this. These angles actually, if you can add the two, then subtract from 180, you can get the required angle at C. That's the concept, right? Let's find angle. So first you say angle TBA is equals to 98 degrees. Then reason, you say the exterior angle of a triangle is equal to the opposite interior angle. The exterior angle of a triangle is equal to the opposite interior angle. Then after that, you find this angle at A and angle at B, angle at T. So angle at A and T using triangle ABT. Angles in a triangle add up 180. So you can say 180 minus 98 divided by 2. Since this angle and this angle, they are the same, I can call it XX. They are actually the same, these angles, right? Why? Because it's an isosceles triangle ABT. Those two sides, they're the same. Therefore, base angles of an isosceles triangle are equal. So 180 minus 98. 180 minus 98, what we get? 82 divided by 2, 41. So these two angles, this one is 41 and this one is 41 degrees. Right, then we can find this angle now that you have marked in blue. You can find the angles marked in blue. This first one, that's angle, is angle CTB. Angle CTB, we can say 180 minus 98 minus 41. Reason, adjacent angles on a straight line. These are adjacent angles on a straight line. You can just say adjacent angles in a straight line. Then it will be 180 minus 98 minus 41. Then you get 41. Which means you can be able to apply also the theory based on the exterior angle of a triangle is equal to the opposite interior angle. If you can check this one, 41 is the same as this 41 here. The same as this one, opposite, right? So this one is exterior to 41 up there. So you can apply the same concept. It applies very well. Right, then we are left to find angle at B. That is angle CBT. Angle CBT, you can say CB, you put an angle sign. T is equals to, then it's 180 minus 98. Reason, you can say adjacent angle. These are adjacent angles. So 180 minus 98, is it 82? 180 minus 98, yes, it's 82. So this angle is 82 degrees. Now using triangle using triangle TCB, triangle TCB, we can say that angle, that the required angle ACT now. So ACT is equals to 180 minus, then you say using triangle BCT, right? So BC is the same as AC. You can say BC or ACT. So you can say 180 minus 82, that is the angle at B, minus 41, that's the angle at T. Then angles in a triangle, that's the reason. Then 180 minus 82 minus 41, what do you get? 57. So you get 57 degrees. So this angle is 57 degrees. Done. So you have to be using your theories to explain your reasoning. Right, then we have this one. That's the other question that we have. Right, based on this one, it's written A, B, C, and D are points on the circle center O. EF is a tangent to the circle at D. Then we have angle ADE is 42 degrees given. Then angle COD is 162 degrees given. Then what did they say? They said find the following angles, giving reasons for each of your answers. Right. Right now, you must show your reasoning. You must be giving the reasons for each of your answers. The first part. The first part is angle X. Angle X, if you can check, is theory number 1. Right? Angle at the center is twice angle at the circumference of a circle. So it will be X is equals to, it's 162 divided by 2. What is 162 divided by 2? 162 divided by 2. It will be 81. So X is 81 degrees. Reason, angle at the center is twice angle at the circumference. Is twice angle at the circumference. That's the reason. Circumference. That's number 1. Then for Y, where is our Y? Our Y is here. It's outside, right? So if you can check Y and X, they must be the same. Why? Because this one is an exterior angle of a triangle. It's equal to the opposite interior angle. So which means my Y is supposed to be 81 degrees. Put degrees. Then the reasoning is exterior angle of a triangle. Of a triangle is equal to the opposite interior angle. To opposite interior angle. Opposite interior angle. Just like that. So our Y is 81 degrees. Right. Then next, we want to find our Z. Right. So to find our Z, we can say, if we can find this angle here. Let me change my ink. Let me mark my angle in red. This is my angle here. This is my angle. If I can find this angle, then I can take cyclic quadrilateral ABCD. ABCD is a cyclic quad, which means opposite angles add up to 180. Right. So first part, angle Z. First thing, I can say I can find this angle, that is ADC. ADC is actually 180 minus 42 minus 81. Reason, adjacent angles on a straight line. This is a straight line EDF. EDF. This one is a straight line. So I can say 180 minus 81 minus 42. I get 57. So this angle is 57 degrees. So 57 plus Z is equals to 180. These are the opposite angles of a cyclic quadrilateral. A, B, C, D is a cyclic quad. All the points or corners that are touching the circumference of a circle. Therefore, it's a cyclic quad. Opposite angles, they are supplementary. Add up to 180 degrees. So I can say 180 minus 57. 180 minus 57. 180 minus 57. What do I get? 123. So this angle is 123 degrees. That's angle Z. Why? These are opposite angles of a cyclic quadrilateral. Quadrilateral are supplementary. Are supplementary, which means they add up to 180 degrees. Done. Right, next. This is the other question. Number 8 in this paper. They say the points A, B, C, D, and E lie on a circle. PAQ is a tangent to the circle at A, and EC is equals to EB. EC. This one. Right, EC is this one. Is equals to EB. This one. If they are the same, That means W is 80 degrees. Why? These are base angles of an isosceles triangle. They are the same. Like this. Then they said ECB is 80 degrees. Then angle ABE is 40 degrees given. Then find V, W, X, Y, Z. Then I've already found my W is 80 degrees. Why? These are base angles of an isosceles triangle. They are the same. Right, number one. Number two, I can find V. V is the exterior angle of a triangle, is equal to 40 degrees. It's also the same as X degrees. So V and X, they're the same. They're the same as 40. So V is 40 degrees, X is 40 degrees. They're actually the same. So even this angle is 40, 40. 40 degrees, 40 degrees. So my X is 40, my V is 40 degrees, like this. Right, then next, since we have found my W, then you can use cyclic quadrilateral ABCD. We can use angle at B is the same as Z, right? But it's plus Z is cos 180 degrees. Why? This one is a cyclic quadrilateral. Opposite angles, they are supplementary, add up to 180. So to find our Z, since we have found our W is 80, so you can say 180 minus 80 minus 40, then it's equal to Z. Then these are opposite angles of a cyclic quadrilateral. They add up to 180 degrees. So it's supposed to be 60 because 180 minus 80 is 100. Minus 40 is 60. Some of the things are meant to work. So my Z is actually 60 degrees. Then what else? I'm left to find Y. Right, Y? If you can check cyclic quadrilateral, EABC. EABC is a cyclic quadrilateral actually. EABC is a cyclic quadrilateral, which means 80 plus this angle Y. These two angles, they are opposite. They add up to 180 degrees. So which means Y is 180 minus 80. So it's 100 degrees. Just like that. Right, then we have this item actually, part B. In the diagram, KL and M lie on the circle, center O. Then angle KML, KML is this one is 2x. And reflex KOL is 11x, which means this whole angle is 11x. Then they said find the value of x. Okay, so we can use this one theory number one. Number one, it says angle at the center is twice angle at the circumference, which means the two angles whose relationship can be found is this and this one marked red. 2x and this marked red is twice this 2x. So this angle is actually 4x, which means 2 times 2x is twice 2x. So it will be 4x. Then angle at a point add up to 360 degrees, which means 11x plus 4x is equal to 360 degrees. Reason angles at a point or angles in a circle. Then you can say 11 is 15. 15x is 360. Then divide by 15, divide by 15. What do you get? 360 divided by 15. You get 24. So our x is 24 degrees. Just like that. Right, we have, right, this one is now based on similarity. Right, let's work on circle geometry. Right, we have this question. Right, based on this question, you can see we have diameter A, O, C. They said A, B, C, and D are points on the circle, center O. Angle ABD is 21 degrees given, and CD is 12 centimeters given. Calculate the area of the circle. Area of the circle, you must find radius AO or radius OC. Actually, we need to find the area of a circle. First thing, angle formed by the diameter, which is angle at. This one, angle at. So you can say angle, you can write it here, angle, then ADC is equals to 90 degrees. Reason, angle subtended by the diameter or angle subtended by the diameter. These are 5 marks. By the diameter, it's 90 degrees. So this angle is 90 degrees. Then this angle ABD, the one given, is equals angle ACD, which is equals to 21 degrees. Reason, these are angles subtended by the same chord AD. Angles subtended or formed by the same chord. By the same chord, that is AD. So this angle is 21 degrees. Right. It means if you can have this angle, then if the side 12 centimeters, we can be able to use SOHCAHTOA to find our diameter AC. So applying SOHCAHTOA or CIRCE, I can prefer SOHCAHTOA or CIRCE. Some old horses can always hear their owner's approach. That's SOHCAHTOA. This one means sine. This one means cos. Then this one means tan. So sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Then tan is opposite over adjacent. So in this case, the side that you want is diameter. Diameter. Because we want to find the area of the circle. So we must find the radius. If we can find diameter, we divide by 2. Then we can have our radius. We can use pi r squared. That's the area of a circle. Pi times radius squared. So diameter AC. So we can say this one is hypotenuse. Then 12, that is CD, is adjacent to 21 degrees. So adjacent in the hypotenuse is cos. So you can say cos 21 degrees is equals to adjacent, that is CD, over hypotenuse AC. So you can say cos 21 is equal to CD, that is 12 over AC. Then you can cross multiply, it will be AC cos 21 is equals to 12. Because this side will be over 1. Right? Then you divide by cos 21. It will be over cos 21 over cos 21. Then it will be AC is equals to 12 over cos 21. What will be my AC? So AC is equals to 12 divided by cos 21. Make sure your calculator is in degrees mode. Divide by cos 21. Then you get 12.85. Let me put 12.85. That one is my AC. So which means my radius is equals to 12.85. That's my AC divided by 2. So I can say divide by 2. Then to be 6.42 or 6.427. 6.427. 6.427. That's my radius. So to find the area of a circle now, area is pi r squared, which means pi times radius, that is 6.427 squared. So I can say this one squared times pi. My pi is here. Then it's 129. Actually, it's 129. 129.76. To 3 significant figures, it will be 120, 123, it will be 130. So it's 130 square centimeters. Done. Next is question number 2 in this paper. But question number 2 says A, B, and P are points on a circle, center O, and angle OBA is equals 38 degrees. Find APB. APB. Right, APB has a relationship with this angle. That is APB times 2 is equals to angle AOB. That's angle at the center is twice angle the circumference of a circle. So to find angle AOB, AOB, you can use this one. This one is radius, and this one is radius. OA is radius, OB is radius. So they are the same, which means it's an isosceles triangle, which means angle OBA that is given is equals to angle OAB, which is equals to 38 degrees. So this angle is 38 degrees, like this. So you can use angles in a triangle to find angle AOB. So you can say that AOB is equals to 180 minus 38 minus 38. Reason, angles in a triangle. Angles in a triangle. So if you can say 180 minus 38 minus 38 or 38 by 2 is still the same. It's 104. So this angle is 104 degrees. Right. Now to find the required angle, it will be APB. APB. APB is AP. So it will be 104 divided by 2, which is equals to, so this one is angle at the center, is twice angle the circumference of a circle. So it's 52 degrees. Done. Next, part B. CDEF is a cyclic quadrilateral, and FC is called FE. FC is FE. Now they've told you everything now. Then TU is a tangent to a circle if there's a center, but there's no center now. Then at C, and angle TCF is 50 degrees given. Find angle EFC. EFC. It means this angle is the one that you want. Right? Use the same concept. In this case, whenever I can see a tangent and a triangle inside the circle, then you can come to remember this concept based on a triangle. The exterior angle of a triangle is equal to the opposite interior angle. So if this angle TCF is equal to angle CEF, why? The exterior angle of a triangle is equal to the opposite interior angle. So this angle is 50 degrees. Then since these angles, they are marked, the lines are marked, it means base angles of an isosceles triangle, which means CEF, which is 50 degrees here, is equals to angle ECF, like this, which is equals to 50 degrees. So this angle is 50 degrees, like this. Then to find now the angle EFC, the required one, you say 180 minus 50 minus 50. Why? You can say angles in a triangle. They are equal. So 180 minus 50 is minus 100. So it's supposed to be 80 degrees. So this angle is 80 degrees, like this. What else? You have to find angle CDE. CDE is this one. Right? Based on this one, given that CDEF is a cyclic quadrilateral, then you can know that this angle 80 degrees and this angle, they are opposite angles of a cyclic quad, which means they add up to 180 degrees. So you can say 180 minus 80 degrees. Why? You can say opposite angles of a cyclic quad, opposite angles of a cyclic quadrilateral. Then it will be 180 minus 80 is 100. Just like that. Then, super. Right, then, right, done on this with this question paper. Then this one, question number 5 in this question paper. A, B, C, and D are points on a circle, center O. Angle COD, COD is 124 degrees given, and angle BCO is 35 degrees given. Then work out angle CBD, CBD. Give a geometrical reason for your answer. Then you want CBD. CBD is this one. So this one you can check. It's a half of COD. Angle at the center is twice angle the circumference of a circle. So it will be 124 over 2. 124 is 62 degrees. Then you can say angle at the center is twice angle at the circumference, is twice angle at the circumference. Angle at the circumference. So it will be 62 degrees. Done. Then next, work out angle BAD. Give geometrical reason for each answer. BAD. BAD. Let me change my ink. BAD is this one. That's the angle that I am looking for. Right? This one, if I can find this angle, that is angle BCD. Then it will be 180 minus BCD. Why? Because the cyclic quadrilateral ABCD is a cyclic quadrilateral, if you can check. All the points, they touch the circumference of a circle. So it will be this one, 180 minus BCD. Why? Opposite angles of a cyclic quadrilateral, they add up to 180. So I can find this angle first. This radius, they are equal. which means angle ODC is equals to angle OCD. ODC is equals OCD. So you can say, find the two. You can say 180 minus 124, then divide by 2. 180 minus 124 divided by 2, minus 124, divided by, it's 56 divided by 2, so it's 28. So this angle, this small angle is 28, this small angle is 28. So when writing here, you say angle went OCD is equals to 180 minus 124, then you say divided by 2. So this one you can say angles in a triangle, or base angles of an isosceles triangle. Base angles of an isosceles triangle, then to give you 28 degrees. Right now, you can say angle that we need BCD is 35 plus 28. 35 plus 28, what you get? 35 plus 28, you get 63. So this whole angle is 63 degrees. Right. So you say angle, the required angle, which is BAD plus 63 is equals to 180 degrees. Why? These are opposite angles of a cyclic quad. Opposite angles of a cyclic quad. Of a cyclic quadrilateral. So they are supplementary. So it will just be BAD is 180 minus 63. You get 117. So it's 117 because opposite angles of a cyclic quad, you can just write this one, angles of a cyclic quadrilateral are supplementary. They add up to 180 degrees, which means they add up to 180 degrees. I'm sure you are blessed. Then after watching, please like, share, and subscribe to this nice, powerful item. Say Mangeya, signing out.